Okay, for this lesson, we're going to take a look at increasing and decreasing functions. So as we work with functions in more detail, we'll need to know where the graph of a function rises and where it falls. This is easy to determine by just looking at a graph. We can clearly see that in this section from A to B, the graph is increasing as it goes to the right. Same thing, C to D, it is increasing as it goes to the right. And between B and C, it is decreasing as it goes from left to right. So we would say that the graph from A to B is increasing and this is on the interval from 1 to 3. It is decreasing on the interval from 3 to 7, and then it is increasing again on the interval from 7 to 10. On an interval where the graph is rising or increasing, the slope of the tangent line at any point in that interval is going to be a positive slope. This means that f prime of x is going to be greater than 0, and this function is said to be increasing when f prime of x is greater than 0. Alternately, on an interval where the graph is falling, the slope of the tangent line at any point on that interval is negative. This means that f prime of x is less than 0, and the function is said to be decreasing when it is less than 0. When we are determining whether or not a function is increasing or decreasing, we always move along the graph from left to right to see what the y values are actually doing or what they're changing by. If f of x is increasing, that's when the derivative is positive or greater than 0. If f of x is decreasing, that's when the derivative is negative or less than 0. So we're going to use that principle for this first example. Find the intervals on which the function f of x is equal to 1 minus 5x plus 4x squared is increasing and when it is decreasing. Well, we know that the increasing and decreasing is based on the idea of whether the derivative is positive or negative. So the first thing we're going to do is we're going to find the derivative. So if I take the derivative of this function, then that 1 is just going to become a 0. So I'm going to have negative 5 plus 8x, or f prime of x is equal to 8x minus 5. The second thing we need is the roots of the derivative. So if 0 is equal to 8x minus 5, then x is going to equal 5 over 8. And if that's the roots, like when we were doing the intervals in the previous lesson, then I'm going to have that 5 over 8 here, and it's going to split into two regions, when it is less than 5 over 8 and when it is greater than 5 over 8. For step 3, we can make a chart like we did in the previous lesson. And we're going to say that we have it based on the 2 intervals. Where one of the intervals was when it is less than 5/8. And the second interval is when it's greater than 5/8. I really only had the one factor, just that 8x minus 5. So I'm going to put that up here, the 8x minus 5. And then I'm looking for f prime of x and how that applies to f of x. So when I pick a number that is less than 5/8, like 0, then I get a negative number. When I pick a number that's greater than 5/8, I get a positive value in here. This means that f of x is less than 0 here, and f of x is greater than 0 here. And that means that when it is less than 0, the original graph is decreasing. When it's greater than 0, the original graph is increasing. And then the last part is my statement. Therefore, f of x is decreasing when x is an element of negative infinity to 5/8 and increasing when x is an element of 5/8 to positive infinity. For example 2, it's asking the same idea. Find the intervals in which the function f of x is equal to x cubed plus 6x plus 6x squared plus 9x plus 2 is increasing and decreasing. So, same steps. Step 1, find the derivative. F prime of x is going to equal 3x squared plus 12x plus 9. Step 2, find the roots. And in this case, if 0 is equal to 3x squared plus 12x plus 9, this is my quadratic, I'm going to factor it. 0 is equal to 3 bracket x squared plus 4x plus 3, or 0 is equal to 3 bracket x plus 1 and x plus 3. Therefore, the roots are x is equal to -1 and x is equal to -3. I can use my number line to indicate that I have 3 intervals here. When it is less than -3, when it's in between -3 and -1, and when it is greater than -1. And I'm going to apply that to my chart. And what am I going to have? Well, I'm going to have 3 intervals. I'm going to have my factors of 3 of x plus 1 of x plus 3, and then I have my f prime of x and my f of x. So I got my factors, 3, x plus 1, x plus 3, my f prime of x, and my f of x. I have my intervals, negative infinity to negative 3, negative 3 to negative 1, and negative 1 to infinity. Well, no matter what number I sub in, 3 is always going to be positive. When I sub in a number that is less than negative 3, then x plus 1 is going to be negative, and x plus 3 is going to be negative. When I sub in a number in between negative 3 and negative 1, like negative 2, then x plus 1 is negative, but x plus 3 is positive. And then when I do a number bigger than negative 1, like 0, then x plus 1 is positive and x plus 3 is positive. Now remember, we're doing product, so we're going from left to right, and we're going to say that a positive, a negative, and a negative makes a positive, which means that this is going to be greater than 0. A positive, a negative, and a positive is going to be less than 0, and 3 positives is going to be greater than 0. What's happening for my function? It is increasing, decreasing, and then increasing. And then last but not least, we have our statement. F of x is increasing when x is an element of negative infinity to negative 3 or negative 1 to infinity, and decreasing when x is an element of negative 3 to negative 1.